Today we're going to talk about how you would graph the equation r equals 1 plus sine theta. So the first thing they want you to do is sketch the graph over the interval from 0 to 2 pi using a rectangular coordinate system. That doesn't mean that you can just substitute y in for r and say that this is 1 plus the sine of x. If you do that, that just gives you a sine wave that's scooted up one. It looks something like this. Okay, that you just can't do it that way. If we want it to be in the rectangular coordinate system, we have to convert this polar equation to a rectangular equation. And that conversion uses the fact that r squared is x squared plus y squared, and that the sine of theta, well, let's do it this way, that r times the sine of theta equals y. So we're going to have to start with this equation and these facts, convert the equation to a rectangular coordinate system, and then plot the equation in rectangular coordinates. So if we start with r equals 1 plus the sine of theta, the easiest way to do it is to multiply both sides by r, because then you lose at least one of your square roots. So this becomes r squared is r plus r sine theta. Now, this is the rectangular coordinate y. We don't have much choice for r. It's the square root of x squared plus y squared. But by making the left side r squared, we get to just use x squared plus y squared and not have a radical. And if you graph this, you get what we see here. I use Desmos. It would be very hard to do this by hand, but it could be done if you set up a really complicated XY table. Now, to graph it in a polar coordinate system, this is already a polar coordinate. So that's very simple. You get polar paper, and when theta is 0, the radius is 1. Let's just go here. When theta is 0, the radius is 1. That's right here. When theta is, what's another easy one? Sine. When theta is pi over 6, the sine is a half, so the radius is 1.5. So here's 1 and here's 2, so 1.5 is right about here. Pi over 3, not so easy, but pi over 2, the sine of pi over 2 is 1. 1 plus 1 is 2. That gives us this point. Back over here to 5 pi over 6. The sine of 5 pi over 6 is a half. 1 plus a half is 1.5, which puts it right here. When we go to pi, 1 plus -1 is 0. There's this one. When we go to 7 pi over 6, the sine is -0.5. That makes the radius a half. 1, 2, 3, 4, 5. We're going to be 2.5. So we're right here. When theta is 270 degrees, or 3 pi over 2, the sine is -1, which makes the radius 1 plus -1, which is 0. When we get over here to 11 pi over 6, the sine is -0.5. Radius is 1 minus a half is a half. So here's a half, and we follow it till it intersects 11 pi over 6. And then you could just draw in the curve.